Hi, and thank you for listening to our presentation on the analysis and redesign of an exercise weight rack. We are Team 7, and we'll go into our presentation now. First, we'll go into the purpose of the product, which is intended to be used to hold a barbell, provide stable and adjustable seating, and facilitate weightlifting exercises. Some design features of the product are the bench assembly, which is where the user would sit or lay down, and it has a stationary section for stability and also an adjustable section that changes the incline angle for various exercises. The rack assembly, which has a bar holder, which allows for the barbell to be held when not in use. The leg curl assembly is multifunctional as it can be used to store weighted plates and perform leg exercises. And finally, the rack assembly also has additional pegs to hold more weighted plates. So on the left here, we have an isometric view of the CAD model. It shows the entire product in the assembled state along with an inclined bench and weighted plates. And on the right, we have the exploded view of the product, which calls out the different sub-assemblies and components. And we'll go more in depth on those in future slides. So the primary customer for this product are commercial gyms and fitness centers, which typically have between 2 to 20 of these exercise racks. It really just depends on the size of the gym and the amount of gym goers that they have. Doing some research, there are an estimated over 100,000 gyms and fitness centers in the US in 2021. So we know that the market for this product is extremely attractive. The secondary customers for this product are residential individuals or families that are looking to purchase this for an at-home gym. Obviously, with the pandemic and the stay-at-home order, the demand for these exercise weight racks skyrocketed, and many companies and manufacturers entered the market space.
So for our functional analysis, we decided that the main purpose of the weight bench was to facilitate exercise. In this case, some variation of a chest press. In order to do that, it must be able to hold a lot of weight. In this case, both the user and a bar loaded with different levels of weight. It also must isolate the press motion and keep other parts of the body still and make sure you're able to get a good exercise form. In order to enhance the product, you should be able to change the incline in order to get those different variations of the chest press. And while you're on the bench exercising, you should also be able to lie comfortably. There are two possible sequences in which the weight bench could be assembled. Sequence 1 puts the weight holding assembly, the ground assembly, and the attachment bar all connected first. Now, the attachment bar and leg curl bar could be attached later towards the end, as seen in sequence 2. Just to recap what I just said, in sequence 1, the assembly sequence allows the weight holding assembly and ground support assembly to provide a base for the rest of the components. And it could also be difficult to assemble the other ones first, since they are attached to the two sub-assemblies in some way. And in sequence 2, like sequence 1, this allows the two large sub-assemblies to support all the other components, but this sequence moves the attachment and leg curl components to the end, since they could get in the way of assembling other pieces, such as the bottom support. In order to analyze these two different assembly sequences, we made this chart, which you can read. So for ease of transferring and handling, sequence 1 and 2 are basically the same ease of locating parts. They're both fairly easy. All the parts have some geometric shape that indicates where they should go. For ease of fastening and joining, sequence 1 is better because in sequence 2, with the seats attached first, it could be more difficult to attach the lower leg assembly later. For ease of testing the sub-assemblies, with the leg assembly attached first, you can test out that functionality, whereas in sequence 2, you cannot test it out until later. For ease of assembling in parallel, they're both fairly bad because they're connected through multiple components, making it difficult to assemble them in parallel. So by using these numbers, we found that sequence 1 was better. For the function component mapping matrix, you can see that many of the parts fulfill multiple functions, but some don't fulfill any, such as the attachment bar, which attaches to the leg curl bar, and essentially functions to only attach the leg curl bar to the ground support assembly. So that could be removed. The plastic inserts also don't fulfill any function, but they could keep bugs out. So that might be nice.
So here we have the bill of materials for our exercise weight rack, which lists the subassemblies in blue and their corresponding components underneath them. For each component, we listed the part name, the quantity, the material, the manufacturing process, and the assembly process. We also provided a rough cost estimate, which includes the material and operating costs per part. Some of the components in our product will be off the shelf from suppliers, so we did not include those in the cost estimation. We simply looked at the components that we would have to manufacture ourselves in-house. Material cost is pretty straightforward, and the information in the lecture slides was used to calculate it based on rough volume estimations from the CAD. The operating cost, however, was a little bit more difficult for the size and complexity of this assembly. We assumed each type of manufacturing process had a flat cost. So for example, since we have not covered injection molding yet, we assume that the manufacturing cost per part would be around 10 cents based on the size of the pieces. And we don't cover extrusion in this class. So again, we took some liberties and assumed the cost of manufacturing those. So adding the material cost and operating cost of each component together, we were able to get a total cost of the entire assembly of roughly around $440. And so comparing to commonly sold exercise weight racks, these range between $300 and $700 for most of the residential type that we saw. I'm not entirely sure what a quote for a gym would be, but we can guess that from our cost estimation and these prices that we saw, that we have a pretty reasonable cost estimation for this product. So a main goal that we have, that we identified from this bill of materials, is that we really want to reduce the amount of parts and steps that are needed to create the final product. So from the BOM, we have around 35 parts. We'd like to decrease that quite a bit. And the steps to assemble, we want to decrease those as well. So here we have the product family design. The functional differentiation table shown here shows differences in functions between the two target customer groups. This table helps explore how variations in a product within its family target different customers. So the functions are taken from the functional analysis system technique diagram that we had in the earlier slides. We can see that many of the exercise weight racks functions apply to both the secondary and primary customer groups, except we targeted the changing of incline to be different for these groups. So whereas this function applies to more of the secondary group, which is the residential individuals and families, it does not necessarily apply to the primary group of the commercial gyms and fitness centers. We decided this because most fitness centers and gyms will typically have a wide variety of weight machines and different bench inclination setups that you can use to target different muscle groups, whereas home gyms are often limited in space and the equipment and budget. As such, having the added versatility of adjusting the incline is a much needed function in the home gyms. So moving forward, we have the platforms versus modules table. The component commonality table simplifies the assembly into two categories. We have modules and platforms, as I said. Modules are components that take different forms in each product variant, while platforms are common components in both product variants. Platform components allow for high variety while keeping a lower production cost, such as the base part that they stem from are the same. For the exercise weight racks, the modules are the main assemblies and beams forming the skeleton of the rack itself. This consists of the weight holding and ground support assembly, as well as the bottom and top support beam. The platforms for the exercise rack come from the function component mapping matrix, and the parts are interchangeable within the family for variation added onto the base modules. So this will be explored further in the interim report that we have, and thank you for listening to us.